you're going to like this lesson because it is really similar. Haha, get it? Similar. It's really similar to a lesson, a whole unit that we did last semester. So title it Similar Triangles. So I have a picture of the pyramid on the back of a dollar bill because this triangle is similar to this triangle. Supposedly. The angle's kind of distorted, so. What unit? Oh, the congruent triangles unit, EAG, is the one that this is going to look like, okay? Similar triangles. Okay, there's two triangles. There you go. Are they similar? Yes, EAG. You've been spelling similar wrong. I'm glad you know how to spell it now. Are these similar? Are they? Yes or no? How would you check? You can't say yes because we don't have any information about those triangles. We don't have sides. We don't have angles. What would we need to check? All three angles, all three sides? What would we need to check? Angle, side, angle, 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 side, 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 angle, side, and side, side, side. You trying to remember the ones from? Well, they're not congruent. That's out of the playing field. So what if I did this? Oh, are those angles congruent? So guess what? I checked one angle, and it was not congruent, and I now know that these triangles are not similar. Not even a choice. Because if two triangles are similar, their angles are congruent and their sides are proportional. If even one angle isn't congruent, then we are out of that ballgame. Sorry. Not similar. See how I'm checking the angles? So, I'm just going to cut to the chase. When we had congruent triangles, we had 5 different postulates that we could choose to prove our triangles guilty of being congruent. With similar triangles, we've got 3. Yay, we have less. 3 different postulates that we can check to see if our triangles are guilty of being similar. What's the symbol we use for similar? Very good. So you can write these at the top if you would like. We're not going to discover them. I'm just throwing them at you. What do you think that stands for? No, Austin, that's congruent. Similar is just a squiggly. So this is angle, angle similarity, side, side, side similarity, and side, angle, side similarity. If you don't put the squiggly, I know that's a technical term, if you don't put the squiggly after the letters, then you are proving them congruent and not similar, and that is bad. So we need to not ever, ever forget our squiggly. You forget your squiggly, you get it wrong. Okay. So, angle, angle similarity. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar, without checking any sides. Now, why is it angle, angle squiggly and not angle, angle, angle squiggly? There's 3 angles in a triangle. How come you only have to check 2 of them? The 2 make the third angle is the same. Right? So if 2 angles of a triangle equal 2 angles of the other triangle, then by default the third angle is going to have to equal the third angle, because all triangles in the universe add up to 180 if you are in Euclidean geometry. Now if we're in spherical geometry, that's a different story. You can take that in college if you want. Alright, I'm going to move on. Helium, I was just talking about helium, sorry, I'm calling you helium because that's what you type in. I was just talking about there's more than one geometry out there. There's other geometries. There's one called taxicab geometry, there's spherical geometry, and in those geometries, triangles don't add up to 180 because it's a triangle on a sphere Like picture that as a sphere. And so the triangle is like that. Does that make sense? Because the triangle's on a sphere, so it's bended. All right. Side, side, side similarity. Now, if you are trying to use the sides to prove two triangles guilty of being similar, you have to check all three. You have to check all three. You have to check all three. You cannot just check two of the sides, or you'll be in trouble. No, we're not checking to see if the sides are congruent. We're checking to see if they're proportional. Not congruent, proportional. So, does 2 go with 4 as 4 goes with 8 as 3 goes with 6? And in this case, the scale factor is 2, and it's 2 every time. 2 times 2 is 4. 4 times 2 is 8. 3 times 2 is 6. So the proportions were maintained. Therefore, those triangles are similar, and we don't need to know about the angles. Now, if you're going to check to see if two triangles are similar, and you don't have a similarity statement, so you don't know which sides go with which side. You have no idea, and one of the triangles has been rotated, so you're just at a loss. When you are comparing them, when you're setting up proportions, you need to put the smallest over the smallest, the medium over the medium, and the large over the large, and you'll be good to go. So, you need to find the smallest side of this triangle. Small side, 1. Small side of this triangle, 3. Medium side of this triangle, 5. Medium side of this triangle, 15. And then obviously the largest side and the largest side. You can reduce all of those. And then when you reduce them all, if they all reduce to the same fraction, then your triangles are similar. 1/3, 1/3, 1/3. Last one of the day. Side, angle, side similarity. This is the last one that works. There's only 3 to keep track of. If an angle in one triangle is congruent to an angle of another, and the sides including the angles are proportional, then they are similar. The most important thing about this theorem is that since the letter A is between the letter S's, the angle has to be the angle that's between the sides. If it's this angle right here, the answer is no. They're not guilty of being similar. It has to be the angle between the sides. Side, angle, side. Okay? And then you check to see if your angles are equal, and you check to see if your sides are proportional. Your sides aren't going to be equal, they're going to be proportional. Does 2 go with 4 as 3 goes with 6? Yes. Alrighty. Now that we know what to do, now we can practice. Determine if the triangles are similar. So remember, we've got 3 choices. This one is either going to be side, angle, side, or it's going to be none. It's not going to be angle, angle. It's not going to be side, side, side. So this one, you've got a 50-50 chance. It's either side, angle, side, squiggly, or it's none. So we need to check all 3 things. Angle, angle, check. Does 10 go with 6 as 15 goes with 9? Does 10 go with 6 as 15 goes with 9? 10 over 6 is 5/3. 15 over 9 is 5/3. When they both reduce to the same fraction, then they are proportional. So determine if they're similar. Yes, they're similar. And what are they similar by? Side, angle, side, squiggly. If you forget the squiggly, you get it wrong. Okay. Yuji's going to put 10 squigglies on hers. Determine if the triangles are similar. So Tahani already wrote side, 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 squiggly. So you already did those proportions. You already checked them. That was quick. Because just because you have 3 sides doesn't mean that those 3 sides are proportional. So it's either going to be side, 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 squiggly, or it's going to be none. But we have to check them. The way that you check them is you find the smallest one, and you put it over the smallest one. Then you find the medium one, and you put it over the medium one. Then you find the largest one, you put it over the largest one. Then you determine, is that a true statement? Are those really equal? No, they're not equal. So that triangle has been enlarged, but it hasn't been enlarged proportionally. Are they equal? Why'd you say yes? Pretty sure they're not, because there's even and odd numbers in there, and they don't, yeah, okay. We could do it in our calculator. We could reduce all of those. Oh, you're saying close but no cigar? Yeah. So 6/14 is 3/7. 9/21 is also 3/7. But then you check 12/29 and it's 12/29. So they are not similar. None or no. No, they're not similar. All right. Uh-oh. Wait a minute. There's no numbers on this problem. There are not any numbers on this problem. So guess what? Make lemonade out of lemons. Yeah. If you know that they're similar and you feel confident about your answer, that's awesome. If you don't know if they're similar, then make up numbers. Let's make up numbers. I'm going to say this is 2 and 2. And I'm going to say this is 3 and 3. This angle, do you agree, is congruent to itself. So I think it's either going to be side angle, side squiggly, or it's going to be none. Okay? So we are comparing this triangle to this triangle. We already have an angle. The angle's good. Check on the angle. Now let's compare the sides. 2 is to, well, that would be 4. 2 is to 4 as 3 is to 6. Well, definitely 2 is to 4 as 3 is to 6. This segment right here is actually called a mid-segment, and we'll learn about that next week. But, so, the conclusion is, the final answer is side angle, side squiggly. We have an overlapping angle. We call that an overlapping angle or a common angle. We have a common angle, so an angle always equals itself. I'm going to move on. So let's compare the left to the right. So we're not using the whole triangle. We're comparing the left to the right. Do you agree that I can add this to my picture? So now we've got an angle. Check. We've got an angle. Now we need to put small over small and large over large. So let's look at this triangle. What's the smallest number of this triangle? 3. Let's look at this triangle. What's the smallest number of that triangle? 9. Small over small equals, what's the largest one of the small triangle? 9. What's the largest one of the large triangle? 27. So I put small over small equals large over large. And that's hard conceptually because we use the 9 twice. The 9 was the smallest and it was the largest, depending on which triangle you were looking at. So if you need to draw those separately, you can draw them separately, or you can put the 9 twice if you want to. 3/9 is 1/3 and 9/27 is 1/3. What symbol is that, Helaman? So these are side angle, side squiggly. You could also do Pythagorean theorem if you really wanted to, and then you could do side, side, side squiggly. But I don't like you to do extra work when the answer is already there, so I would not recommend that one. I think this is the last problem. No. Okay. I know we're getting close on time. So to be able to solve for x and y, our figure would have to be similar. Our triangles would have to be similar. So these two triangles are guilty of being similar by angle, and then look, parallel lines. So that angle is the same as that angle, and that angle is the same as that angle. So these triangles are similar by angle, angle, squiggly. Now that we know they're similar, now now you're just playing with symbols. Now we're allowed to set up proportions. We weren't allowed to until we knew they were similar. Let's do x first. Let's do x first. This is really important, guys. This is an important problem. You need to find that whole side. You need to find that whole side. 15 plus 6 is 21. So I'm going to say, how do I want to do that? Yeah. 12 is to x as 15 is to 21. This is really important. I'm putting the side of the small triangle over the side of the large triangle. And then the side of the small triangle over the side of the large triangle. I did not use 6 in my proportion. 12 is to x as 15 is to 21. Very important. Okay, 12 times 21 divided by 15. 16.8. Can you confirm that? Now let's find y. I never recommend using a freshly found answer to solve for your next one. You need to use numbers that were already there. So for y, I'm going to use numbers that were already there. I'm going to say 10 is to y as 10 is to y as, you can use 5/4 if you want. I'm just going to keep using the sides because I kind of let my calculator do it. No, Yeji, that's the problem. It's not 15 is to 6. There you go, Taha. 10 is to y as 15 is to 21. We can't use the 6. The 6 is not a side of a triangle. The 6 is a portion of a side of a triangle. So that's what I really need you to be careful about, not using the 6. I know your bell's about to ring. George, I'll look at that problem. I will look at it. 10 times 21 divided by 15. It must have just been an error in the grading, George. And then, Tahani, you need the quiz link. That's why we just have to take quizzes the day I give them. 14. And we're going to stop for today.